when I have a problem like this, okay, this one is easy to find some points. If I wanted to start plotting points, how would I do it? Plug in 0 for x, maybe for y. Yeah, that would give me the x and y intercepts. We talked about that. Okay, what else could I do? That would give me 2 points, right? Or maybe more. 3. You could start putting in other numbers for x or y, right? Now, what if it said x to the 12th power plus 2x minus 5? Can I do the same approach? How hard would it be? Could I find every kind of intercept? Let's see. So here's my little calculator. I'm going to go ahead and type in 3 times 0, 0 squared. Well, let me put that in parentheses. Plus 2 times 0 minus 5. Okay, so I just learned that one of the points that would be a point for this relation is the point 0, negative 5, right? And if I wanted to find another one, I'm going to hit the second key here. You guys know about this probably. How many of you have used these calculators? A lot of people have, but not everybody. But I can pull up, if I hit second entry, I'll get the exact same thing on my screen. So see, it comes up again. And I'm going to change all these zeros to some other number. So let me put in a 1. Right? Oh, wow. I got 0. Oh, this is all completely wrong. Thank you. Let's try it again. 0, negative 5 is still going to be right. Okay, so let's change the exponent here. We don't want that. So I'll delete that, and I'm going to insert, well, I need caret 12. There we go. Oh, it's still that. The 1 is still the same. But now when I go ahead and put in like 2, where the 1's are, how about that? 12,287. Wow. So you could graph this thing eventually, but right, it'd be difficult. Okay, it'd be difficult. And yet, could I get a graph if I scaled things correctly? Sure, because this is a special kind of relation called a function. Now, how do I know if a relation is a function? The vertical line test. What does that mean? The vertical line test is a really nice way to say it. I'm also going to say this about a function. Each input has exactly one what? Output. Input and output, if I'm going to use those words. Of course, the mathematical words that you read about, if you read the section for today, is that the set of all inputs has a name, and it's called what? The set of all inputs is called the domain. X. Yes, if we write y and x, then yes. Now the reason I'm not going to stick myself to y and x is later I might write something like this. I might write, hey, we have a function, y is a function of t, okay? Then what's the input if I write this notation like this? T, whatever's in the parentheses. And the output would be f of t, or y, depending how you say it. Okay? By the way, there's also a name for the set of all outputs. And what would that be? The range. But this was in the reading for today. But one thing I thought that might be nice, and you notice I'm still avoiding number 56. I'll get there. Okay. One thing I thought that might be nice would be to take these exercises we worked on today and to talk about some of these ideas. See, number 20 was the first problem we did. And I guess it's not really a function. How come? Yeah. When you talk about a vertical line test, let's just think about this vertical line, which happens to be the y-axis. The equation of that line is? Give me a rule that every point on that line satisfies. X equals 0. Every point, 0, 0, 0, 1, 0, 2, right? They all follow the rule x equals 0. Well, when my x is 0, I notice my y could be 4 or 4.5. There's a lot of points that correspond to that input, so that's not a function. That's not a function. Whereas, when I was over here, and I was talking about the points, let's see, I had 0, 0, and I had 1, 1, and I had 2, 4. And then some people said, hey, I know a rule for that. This is a function because each input has exactly what? One output. Yesterday, if you still have the What If This Were a Quiz 1.2, I asked you guys to graph this relation, the set of xy's such that, well, let me do number 1. The set of xy's such that 2x plus y equals 4. Right? Well, so I said, give me some points. Well, one thing that was nice, a lot of people realized that you can write this as y equals negative 2x plus 4. And so now, is this a function? Is it true that every input is going to have one output? Hey, let's talk here. For number 3, I said, hint, try letting one of the variables equal one of these guys. All right. So should I try, let's let x equal 3. See what happens, just to try. So then, my equation would say 3 squared plus y squared equals 25, right? So let's see, y squared is equal to 25 minus that 3 squared. 25 minus 9, right? So y squared equals 16. So what does y equal? You sure? Aren't there 2 possibilities? That's bad. Plus or minus 4. I mean, I don't know if it's bad, but what it means is not a what? Function. Why? Because there are 2 possible outputs. Here, guys, let me draw the picture for you. When I have an input of 3, my output is plus or minus 4. So here's positive 4, but here, 1, 2, 3, 4 is negative 4. You guys see that? I like to explain functions using the video game analogy. So, number 3 is not a function. By the way, I don't know if you're familiar with this. Do you guys know this equation, if you were to graph all the points, what it would look like? It would look like a circle. And by the way, it has everything to do with the distance formula, and this is discussed in the book. And we will discuss it later in the course. But there is the set of all the points. And now just to answer your question, should this be solid? Sure. That's the set of all the points that satisfy the equation x squared plus y squared equals 25. And by the way, that's like the end of the course we come back to this. Okay? Not a function. Doesn't meet the vertical line test. What about number 1? Is that a function? How do you know? Well, for one thing, if I can get y by itself like this, then whatever I put in for x is going to give me a unique y. And that's how your graphing calculator works, right? If you go to graph, what do I press? I press y equals. You have to have the y by itself in order to graph things. So if I type in negative 2x plus 4, and if I'm in the square window, I guess. Oh, that didn't work. I'll try this. Well, it worked, but it's not what I wanted to show you. Let's go to the standard graph. There's a pretty good graph picture of y equals negative 2x plus 4. You guys already know how to graph lines, so I'm not going to spend a lot of time on it. Okay? But that's the picture we would get. But now back to number 56, which was asked about. Go ahead. Oh, number 2? Okay, I'll do that. I guess I would do this. How would I use set builder notation? Okay, well, here, guys. The set of all points x, y. How would I start writing that green? I think I would do this. Is that okay? And then where it says such that, I know what I'm going to write. What am I going to write? And then I think I would write, well, either 2x plus y is 4, or y equals negative 2x plus 4. Something like that. That's it. I understand set builder notation is still foreign to you. It's not difficult. It's just you haven't seen it much before, or ever before. And so we're learning this foreign language. By the way, just to finish the quiz, I guess, what kind of symmetry does this relation have? All kinds of symmetry. X-axis, Y-axis, around the origin, and we'll be talking more about those. Wow.